In this video, you will learn how to compare two fractions using the symbols for greater than, less than, or equal to. I like to think of it as the Pac-Man sign, and it's open to eating the bigger fraction or the bigger number. So here we have a visual model of two fractions. We have 2/4 and 3/4, and they are both broken up into the same amount of pieces, 4. So they each have 4 pieces, but they have a different amount shaded. So the first fraction has 2 shaded, and the second fraction has 3 shaded. Since the parts are the same size, we know that 3 is greater than 2. So 3/4 is greater than 2/4. We can also say 2/4 is less than 3/4. Let's try another. Here we have 3/8 and 1/8. They are both broken into eighths, so the pieces are all the same size. So since they are the same size pieces, we know that 3 is more than 1. We can go ahead and show the greater than sign eating 3/8. So 3/8 is greater than 1/8. You can also look at the shading on the model and see that 3/8 fills in more of the circle than 1/8. Now let's take a look at two fractions without a model. So we have 8/9 and 1/9. Since they both have the denominator of 9, the pieces are the same size. So when the pieces are the same size, you look at your numerator and see how many pieces you have. 8 pieces is more than 1 piece, so we'll go ahead and put the greater than sign eating the 8/9 over the 1/9. Another way to do it is using something called cross multiplying. You draw arrows going from the bottom, the denominator of the first fraction, to the numerator of the second fraction, and draw the arrow. So that's multiplying 9 times 1, and we're going to put 9 up here. Then we'll do the same thing starting from the denominator of the second fraction, going to the numerator of the first. 8 times 9 is 72. Since 72 is greater than 9, we can see that 8/9 is greater than 1/9. Cross multiplication is a great way to check your work just to make sure that you did the comparing correctly. So we can start out by looking at this next problem. We can do cross multiplying right off the bat, or we can think about what these fractions represent. So since they both have a denominator of 6, that means that the pieces are the same size. So we can look at our numerator and see how many pieces we have. Since 4 pieces is more than 3, we'll go ahead and say that 4/6 is greater than 3/6, or 3/6 is less than 4/6. And if we wanted to check that with cross multiplying, we'll go ahead and draw our arrows. 6 times 4, and we put 24 up here. And 6 times 3, we'll put 18 up here. So since 24 is greater than 18, that symbol will still be the same way. This is an easy one. Here you have 1/2 and 1/2. Since they both have the same numerator and the same denominator, we can say that these two fractions are equal. Now let's start talking about comparing fractions that have the same numerator instead of the same denominator. Here we have 5/9 and 5/7. That means that we have 5 pieces on each fraction, but the pieces are different sized pieces. Over here, they're ninths, and over here, they're fifths. So a lot of students think that since 9 is bigger than 7, that 5/9 would be greater than 5/7. But think of it like this. Imagine these as pizzas. If you had to share with 9 people, you would get a smaller slice than if you had to share with 7 people. The less amount of people that you have to share with, the greater the pieces are going to be. So sevenths are actually bigger than ninths, and you can tell by the size of the slices that sevenths look bigger than ninths. So if you have the same amount of pieces, we can say that 5/7 is greater than 5/9 because you get 5 pieces on each pie, but the sevenths are bigger than ninths. You can go ahead and check that problem with cross multiplication, just like we did with the other fractions that had the same denominator. We start from the bottom and go up to the top. 9 times 5 is 45. Make sure you put it where the arrow is. And then 7 times 5 is 35. So since 45 is greater than 35, we can say that 5/7 is greater than 5/9, or 5/9 is less than 5/7. Let's try another one. Here we have the same numerator, 4, which means that there are 4 pieces, but our denominators are different. We have 6 and we have fifths. So like I said in the last problem, When your denominator is smaller, that means the pieces are bigger, because if you think of it as sharing with less people, you're going to get a bigger part. So fifths are greater than sixths. As long as you have the same amount in your numerator, you can say that fifths are greater than sixths. So 4/6 is less than 4/5. You can check that with cross multiplication. 6 times 4, 24. 4 times 5, 20, and you will see that 24 is greater than 20, so we are correct in our comparison. Now let's talk about ordering fractions from least to greatest. So we have 3 fractions, and we want to put them in order from the smallest, medium, and largest. So they all have the same numerator. So that means that there is one piece no matter what. But the denominators are different. The size of the pieces are different. We have ninths, we have thirds, and we have sevenths. So we think about the size of the piece. If you have to share with 9 people, you're going to get a smaller piece than if you have to share with 3 or 7. So ninths would be the smallest fraction. 1/9 is the least. Then we're left with 1/3 and 1/7. 1/7 would be less than 1/3, because if you have to share with 7 people, you're going to get a smaller piece than sharing with 3. So that leaves 1/3 as our greatest fraction. 1/9, 1/7, 1/3 in order from least to greatest. Let's continue to order from least to greatest. So this set of fractions is just like the last set, where the numerators are the same, but the size of the piece, the denominators, are different. So don't get tricked into thinking that 7 is the biggest number, so sevenths are the biggest fraction. Remember, if you have to share with more people, the size of the piece is going to be smaller. So our greatest fraction would be 2/3, as long as the numerators are the same. So after 2/3, we would have 2/5, and then 2/7. 2 pieces no matter what, but the size of the pieces are different. We have thirds, fifths, and sevenths in order from least to greatest. Now that we have ordered them from least to greatest, you can actually use cross multiplication to check your work. So we'll start just like we did with comparing. 7 times 2 is 14, and 5 times 2 is 10. So we are in order from least to greatest with these 2 fractions. And let's go ahead and do the same thing with our next 2 fractions. We will do 5 times 2 is 10, and 3 times 2 is 6. So again, we have least to greatest. So cross multiplication is a great way to check that your fractions are in the correct order. Now let's practice ordering from least to greatest with 3 fractions that don't have the same numerator, but they have the same denominator. So remember, the denominator tells you that the pieces are all the same size. So since we have eighths, eighths, and eighths, they are all broken into the same size pieces. So we can look at the numerator to see how many pieces we have. So 1 would be the least amount of pieces. So 1/8 is the smallest. Then we would have 3/8, and 4/8 would be our greatest, because our pieces are all the same size. So then you look at how many pieces you have. 1, 3, 4. Remember that cross multiplication is a great way to check your work. So let's go ahead and check our work. 8 times 3, 24. And 8 times 1 is 8. So yes, we are so far in order from least to greatest. So then we can check our next 2 fractions, and we can go 8 times 4 is 32, and 8 times 3 is 24. So again, this checks out that we are in order from least to greatest. Let's try one more with 3 fractions that have the same denominator of fourths. So all of the pieces are the same size, so you look at how many pieces you have. The least would be 0, 0/4. Then we would have 1/4, and then we would have 3/4. You can check that with cross multiplication. 4 times 1 is 4, and 4 times 0 is 0. So far we are good from least to greatest. And then we will check our next set. 4 times 3 is 12, and 4 times 1 is 4. So again, we check out least to greatest. 4 is less than 12, so our fractions are in the correct order. Thank you for watching my video. I hope it helped. Check out my Teaching Exchange Classroom for worksheets and centers, and download the Grade 3 Fraction Bundle for more practice with this concept.